Let's create a list of strings on the heap, populate it with some default data, print it out, and then delete the list from memory. In main, we create the list here, populate it, print it, and free it here. You'll notice this is the memory address of string list, effectively making it a triple pointer. We'll go over why we're using a triple pointer in string list free at the end of the video. We need to know how many strings are in our list. We can then allocate memory for each string. Each string is represented by a pointer to a character. Before we finish, we need to null out each and every slot of our list, because right now each entry is pointing to random data. We don't want to read into random data. It would be much safer to just have a null pointer dereference error than just reading random characters. We'll populate the list by providing the list, the number of strings in the list, some default text to put in each string, and then the max size of the buffer. We'll do some error checks here. And we also want to make sure that the default text does not exceed the amount of characters we've decided to allocate for each string buffer. Each string needs to be individually allocated. So as we go through the list, each time for each entry, we allocate memory. We take the size of a single character, multiplied by the number of characters in each string. You notice that the number of characters is the string max length, that buffer size from earlier, plus 1 for a null terminator. Just to be safe, we'll put a 0 at the very end of our buffer, right here in the diagram. This is so if we accidentally just write this and we forget the null terminator, we won't read off into a random memory that we don't own. Sure, we will read off into these slots and we have no clue what's there, but it's a lot better than reading off into just random memory, because we own this memory. Weird stuff will happen, but not as weird as what will happen if you go past here. We'll copy over the default text here, and we'll put the null terminator where it actually belongs, right here at the end of the string, and the diagram right here at index 5. The last step is to put the string we've just created into the correct slot of our list. To print off the list, we need to provide the list and the length of the list, and we'll print it off with 3 places of padding. Here's the index, and here's the actual data. So the actual data is represented by this %s, and the index is represented by the %3d. The 3 standing for 3 spaces of padding, the d standing for decimal type. With that, we should probably run it. So I've already ran it before, so let me just clear the screen and show you it. So we have 0 through 7 because we've decided the list will have 8 characters. We've decided that the default text will be apple. So nothing surprising there. Finally, freeing the list. We have to undo everything we previously have done. So we need the same number of calls to free as we had to malloc earlier. Here's our triple pointer. You'll notice how I broke up the syntax here. This is me trying to emulate a reference. If you're familiar with C++, you'll know what a reference is. C only passes by value. There's no such thing as passing by reference in C, so this is my way to emulate it. A reference should never be null, so I'm just checking for this right here. If there's no strings in my list, I think of that as erroneous behavior. I'm just going to crash. I'm not going to handle that. This, just to make life easier to work with, we'll dereference once to get what we think we should usually be working with, right? This makes more sense than a triple pointer. We can then go through our list, and if the entry in our list is null, we're also going to throw error. Because why would you allocate a list and then not put anything there in one of the slots? That just makes no sense to me. I don't work that way. Some people might, but for me, if that happens, it's probably an error in my code somewhere else, so I'm going to crash. Otherwise, if a string actually exists at that index, we can free that string's memory. Then we'll null it out just to be safe. This is a good habit, but it really doesn't need to be done right here. This is also a good habit. it more so needs to be done than this line. After we've freed each individual string, we can free the list itself. And then, because we've passed by reference with my weird convention, we can null out the pointer. That way, you don't have to remember to null out the pointer after the function call, because the function will do it for you, which is nice. I'll stop here on the build script so you can take a look at that. As always, you can message me for source code.